Let's start with a simple code segment. The goal of this code is to count from 1 to some number, in this case the number is 10, and then back down from that number to 0. At the end, the code should print out just the final number. Our only print statement is at the very end, so it should only print the final number that it reaches. As before, don't worry too much about how this code works. You don't need to understand the syntax here to understand this example. So when we run this code, what happens? Nothing. Nothing happens. We might notice, though, that our computer fan starts to work overtime and it might act a little sluggish. In evaluating the results of running our code, we note it just runs and runs and runs and it never outputs anything. There is no error message, though. Because the code ends on a print statement, though, we know that it's never reaching that line because it never actually outputs the results of that print statement. Where is it getting stuck, though? Well, right now we just don't know. But the results of this execution still tell us what we need to do next. We need to go back to the first step of our programming flow and write some code that will help us narrow down where the error is occurring. So let's do that. Here we've revised our code, but the only thing we've changed is we've added a few more print statements. This won't fix the problem, of course, but this way we can look at the output and see how far our code is getting before it gets stuck. So when we run this, we see that it successfully starts the first loop, and so we know it's successfully running lines 1, 2, and 3, because line 3 is the line that actually generated that output. We also see that it prints first loop done. That means that it must run lines 4, 5, and 6, because line 6 was the line that generated that output. And of course, we also see that it runs line 7. We see the output over here, but we also see there's nothing really that could happen between line 6 and 7. They're just two print statements back to back. We probably didn't even need the second one. However, nothing happens after that. That means we know that our problem is occurring sometime on these two lines, lines 8 and 9. We know that because if it was running those lines successfully, it would certainly reach line 10. And we would see second loop done written over here. So now by adding these print statements, we've localized the problem. Instead of it occurring somewhere in our code and we have no idea where, we know it's occurring on lines 8 or 9. So let's focus on what's going on in lines 8 and 9. Well, recall that our goal was to first count up and then to count down. The first part would count up, and the second part would count down. Based on that, we might notice that right here, we have a plus sign. If we're counting down, do we want to add or subtract? And we might not know how this code actually works, but we know that when you're counting down, you're generally subtracting 1 each time. So let's try replacing that plus sign with a minus sign and seeing what happens. Sure enough, with that change made, we see that our output now matches what we would expect. The first loop starts, the first loop ends, the second loop starts, and the second loop ends, and then we get our final number that we expected. We revised line 9 to subtract instead of add, we ran the code again, and we received the output we expected. Now at this point, we might go back and remove those extra print statements we added, because we didn't need them for the final operation of our program. We just added them so we could figure out what was going wrong. Now that the problem is resolved, we don't really need them anymore.